There we go. So, like I said, again, welcome everyone, and happy Tuesday. So today, here's what we're going to be talking about. It's kind of rivers with a focus on Central California. So we are going to be looking at some of the river basics and different river properties. You guys are going to go on a little virtual tour today of the Tuolumne River and see what you notice from the headwaters down to the mouth. So basically from where it starts to where it ends here in the Delta. And then we'll be getting into talking about floods, which is pretty appropriate for this time of what's happening in the last last 3 days or so. And then we'll talk about groundwater next week and have some activities revolving and relating to groundwater next week. I think it'll be pretty cool and pretty interesting, I hope, for folks. So that's where we're headed, right? We're looking at some geo news. Where does our water come from? A virtual Tuolumne tour, do some river basics, river characteristics on Thursday here, some river feature identification on Google Earth on Thursday, and that's where we're headed. So a couple things. I just want to show y'all what happened here. And I didn't get some of the satellites just because I didn't want to spend too much time on it yet, because I would talk all day on it. But the storm that came through, this atmospheric river that we were talking about last week on Thursday, like had the potential to come through, it manifested, and it really was the lowest air pressure ever recorded in that region of the Pacific Ocean. And so low pressures correspond with really strong storms. And when that happens, it's just chaos. And so there were hurricane force winds up by Oregon and Washington, driving waves that were 30 feet tall out in the coast. But what it did for us is drive that atmospheric river right over the top of mostly, Sacramento or Stockton North, kind of between Stockton and, Chico is kind of where the atmospheric river just hung out for over a day in the Bay Area as well. And they ended up getting in Sacramento about 5.5 inches of rain in 24 hours. So, it's kind of amazing and crazy to think about, right? They just set their record and our record for the longest dry streak in history, for the most days without rain in history. And then less than a week later, they get the most amount of rain they've ever gotten in a single day in a 24-hour period, which is like 5.5 inches. To put that in perspective, it's over 65 or 70% of what they got all of last year. And they got it in this one storm. And so some people are like, yay, the drought's over. And that's what these little two graphs are trying to show you here. I just want to make sure that you see here that here's Lake Oroville, which is one of the largest reservoirs in California, stores millions, a couple million acre feet of water, maybe close to 3 million acre feet of water, if I'm not mistaken. I'll have to double check that. But it basically shows you where the water levels were at this time in 2019, 2020, and where it was. And yeah, we've come up in some cases almost 30 feet at Lake Oroville, but it's still 100 and almost 140 some feet or 130 some feet below where it was 2 years ago at this time. And for Don Pedro, we didn't get nearly as much rain here. By the time the atmosphere got into here, it was mixing with some cold water or cold air. So it was getting a lot more snow. And I'll show you the result of that in the Sierra in just a minute. But here's where Don Pedro's at right now, as of this morning or last night at midnight, I guess would be the best way to say it. And it's come up a little bit, but not nearly to where it was back in 2020 and 2019, when it was pretty close to being full there in July of 2019. So we got a long ways to go, but it's a good start. And there's also a cool little website I've put here if you want to take a look at all the different stream gauges. And we're going to be looking at these on Thursday as well. But these basically show you where the streams are flowing and how fast they're flowing, how much water is moving through them. And the color correspondings here represent, are they all-time highs for that day, or are they much above average, or like just a little bit above normal, or below normal. And it's kind of interesting that you see some of our rivers here are still below normal. And that's because a lot of the runoff from the Sierras got caught behind Don Pedro and some of these other dams and weren't being released as much. But like I said, in Sacramento, 5 inches in the valley, that's a lot of runoff already, which is pretty nuts. Oh, this is what I wanted to show you too. But here's kind of the results. This is a live webcam right now up in Yosemite. So if you're looking for something to do this weekend, there you can definitely go to Yosemite Valley. There should be lots of snow up around the peaks and looks pretty great. The Yosemite Falls is also just ripping right now. This is a live view of Yosemite Falls, and just a really cool, pretty thing. You can't get up high. The roads are closed because of all the snow. Some places they got like 3 feet of snow up there. But they may open if we don't get snow again for another month or so or something like that. So we'll see how that goes. All right, so that's kind of what you need. Oh, and we talked about mass movements last week, and sure enough, along the Feather River Canyon up north, I don't have any pictures for this one yet, but along the Feather River Canyon on Highway 70 and some of those burn scars, they had a pretty big rock fall that closed Highway 70 down. So just like we were talking, water is one of those triggers, and got a lot of water and down goes the rocks. So that's kind of the geo news you need to geo knows for right now. And we might get a shower or two later on this afternoon, like far outside chance in Turlock. The further north you go, you might get a sprinkle here or there this afternoon. And then we'll just have to hold our breath for the next storms to develop and hopefully bring something. Halloween, maybe this weekend, there might be a chance of rain up north. Doesn't look like so much here in the valley at the moment. So just something to keep your eyes on and be wary of, all right? So we are now moving kind of, out of the geosphere. We've looked at soil and things last week. This week, we're going to be looking at ideas. And this is a fairly straightforward sketch notes here. It's a pretty easy, not too demanding type of one, hopefully allowing y'all to get some time to catch up on some of the other ones that if you need to. I'll be doing my grading rounds again here coming up this week. So just make sure you get as much as you can in, to the best of your abilities. And that's what we're going to be looking for. So for the first one, we're just drawing a drainage basin with all these different things, or a small graphic that contains the following. And you'll see a graphic like that coming up a little bit later on. And then what I'd like you to do is just kind of label on your graphic or your illustration where you can find the following things happening in rivers, like erosion and transportation, deposition, all that good stuff. All right, so that's what we're going to be shooting for, and that's what we're going to be looking at. All righty. There's a little video at the end of this called the arc storm, which imagine all of the rain we got the other day, and imagine now that happening for 20 or 30 days in a row in California, and turning the entire Central Valley into a 300-mile long lake. And that's what's happened in the past as recently as the 1860s. We got to learn about that and figure out how to deal with that kind of stuff, right? And then you'll see what this sketch is about right now in like 20 seconds. We can just attach a picture of that onto a slide as well. And then the big extension question here is, how might rivers affect human populations in the future of Central California? So support your claims with some of the evidence of the learning you learned in class tonight, all right, or today. So some ideas to consider. What steps can humans take to increase beneficial impacts of flooding, both human and natural, right, on humans and on nature, like ecological type stuff? And what types of things, what can we do to mitigate some of those negative impacts of river flooding on humans? So don't be afraid to have creative solutions. That's what the world needs, and that's what we're looking for, as long as it's evidence-based on some of the things that we talked about tonight. All right, so here's what I'd like you to do, and we're going to spend the first 5 minutes here on this. And what you're going to need to do is you're going to need to get a blank piece of paper or something like Sketchpad or something like that, okay? And we're just going to spend the first 5 minutes. I want you to think, and I want you to sketch, and I want you to draw out, how does water come out of our tap? Where does it come from, right? You go to your tap water, you turn it on, and water comes out, and we can drink it, and it's clean and stuff like that. So my question to you is, where does it come from? How does it get to here? So I want you to spend 5 minutes and draw a very cartoony schematic that shows, hey, water started here, went to here, to here, to here, to here, to here, to get to your sink. All right, do it to the best of your abilities. I don't want you to Google it. That's the whole point. The whole point is to kind of do what you think, your preconceived idea of where this water comes from. It's a big deal. All right, so I'll give you 5 minutes. You can start with the faucet down on the right-hand side, and then you can start building backwards of where does that water come from? How does it get to us? If you live in Modesto, it's going to be different than folks that live in Turlock or, Manteca or places like that. So there's different options, different choices, and I just want to see what you got. So I'm going to give you 5 minutes right now. Go find a piece of paper. This is one of the things that you have to attach to your sketch notes, right? To do that. So I'll put the timer on for 5 minutes right now. We're not going to do breakout rooms for this or anything, but just let you guys sit there and draw and do your best sketch of what you think it takes for water to get there. All right, so I'll stop talking now. I'll put the timer on for 5 minutes and then we'll come back. So for the folks that are just joining us, what you're doing is taking a blank piece of paper and from your memory only, or your ideas only, trying to display or make a quick sketch of how does water get to your sink. So when you turn the water on, where does it come from? How does it get to your house, right? And try to go back as far as you can think of to where that source of the water is and the steps that it takes to get there. So I'm going to give you 5 minutes. It's just supposed to be a quick draw it out as fast as you can idea. All righty. So yeah, now I'll stop talking now that everybody's here and put myself on mute, put the timer for 5 minutes and sketch to your heart's content here. All right, so go. Alrighty, so hopefully you have some interesting ideas. And before we move on, does anybody want to take the plunge and share what they drew? Or you can hold up to your camera if you want to. If not, that's fine too. But where do you think it comes from? Anybody want to take a stab at that before we move on? All right. So just take this picture, remember, and this is what you're drawing here, and this is part of the sketch notes to put on there. And let's see where it comes from. And so I'll give you some past, oops, just made my face big, sorry. Here's some past ideas that I've done this with lots of different folks, from high school students all the ways to teacher trainings and others, university students as well. And here's some of those ideas, right? There's their sink comes to a water filtering place, and pipes go to your sink, which comes from a lake in the mountains, which, depending on where you live, isn't quite too far off, a few steps here and there. This one's kind of cool, like rain in the mountains. Rain falls down a waterfall, and then I guess we're following this path here, like a family circus here. And then it goes into a guarded section to purify it, which then gets pumped into like a water tower or something, and then underground, and then into the sink, into the kitchen. So that was a pretty interesting idea. This one, again, from the reservoirs through the canals into a filter into your sink. And sometimes rainwater can be collected and filtered into your sink. So there's all these really interesting, just kind of cool ideas. Like I thought this one was kind of cool, where sewer water is getting filtered and put back into the sink. And believe it or not, this is happening in a few places now, where sewage is being treated, because we're in such droughts and such having a hard time managing our water. We can purify and clean sewage so that it's super duper duper clean and completely 100% able to drink it. It's how astronauts do it. And it's a good way of, if you don't treat it quite as much, you can use it on lawns and outside places to water, but you can treat it even more and it becomes super duper drinkable, which I would suspect is going to be us, in the coming decades here in California for sure. So a couple of things. I just love this little comic, right? Rivers are one of my favorites. It's like, look, a trickle of water running through some dirt. I'd just say our afternoon got booked solid. And, if we were in person, I'd bring in some small stream tables and stuff, and we would play around a little bit with those, just to see how the water and rivulets move through time, through these different sediments and soils, and how they cut things and deposit things. And it's just kind of mesmerizing. There's just something about being around flowing water, at least for me, that's pretty great. And it works like that for me in nature too. So being around rivers, creeks, and streams, that's my happy spot. And if you haven't had a chance to enjoy that, I mean, we live in a land of rivers, and so many folks, we just overlook it, right? We drive over it on the highway, over the Tuolumne, or over the Merced, or over the Stanislaus, and we don't ever really give it a second thought. So one of the first things we're going to be doing today is trying to get better acquainted with our river, the one that we're all probably most reliant on if you live in the Turlock or Modesto area. And so we're going to take a look at the Tuolumne River here in just a second. But just to kind of reiterate, and if you are going to be teaching, this is a great little water cycle. It's a very in-depth water cycle that's kind of nice and cartoony here. That you can borrow from the United States Geological Survey and their water areas. But you can see the water cycle. You probably learned about it in school, right? It starts with precipitation or snow or things like that, and you get the snow melt and the runoff, and then that turns into the rivers, which turns into the stream flow, which goes downstream. And sometimes they get caught up in lakes. Then they'll evaporate off the surface here of the ocean, or evaporate off the surface of lakes. Sometimes they'll go into the ground and become groundwater, which we'll be talking about way more in depth next week. But right, rivers all start with this water cycle. And what we're going to be focusing on today is kind of this precipitation and runoff. And boy, oh boy, did we get some precipitation and runoff in those rivers this week. So a couple of terminology things I just want to share with you before we start getting going here, all right? Here's Hatch. This is basically series. Here's the Tuolumne River, a Google view of Tuolumne River right here, meandering. And so when you call these lazy kind of turns like this, it's what we call meanders in a river. But what's kind of cool is this whole deal is called the stream channel. Where the river flows is the stream channel. And some of these things that they make like this are called meanders. And this thing lives within what we call a floodplain. So that stream channel, whenever the river gets too much water that it can't hold in kind of its normal flow of that time of year, it fills up, it gets a little higher, and it kind of goes between what we call this little bank full elevation, or it fills its bank. And then if we have a flood, it rises just a little bit higher and can spill out in between these areas. And that's what we call a floodplain. And so we'll be coming back to this idea about floodplains in just a few minutes here. But I just want you to know that's what we call the stream channel. So what we're going to do now is we're going to go on a virtual Google Earth tour here of a whole bunch of different places on the Tuolumne River. And so let me get the Jamboard. I think I have the wrong link on the slides here. So let me copy this link. I think we can edit it all. Yep, let me put that in the chat. All right, and so you guys are going to get this Jamboard open, and you'll notice that it says, and did I make all the groups funny on this one? No, I did. Okay, this one's good. So basically what you're going to be doing here is you're going to be flying to spot to spot to spot in these different Google Earths, very similar to what you did with the landslides and the mudslides and stuff like that, except this time there's not very many videos or anything like that. The whole idea here is you're going to be flying into Google Earth and Street View. That's what I'm trying to say. And so let me get this open. Copy link address, put that in here. So that second big one here is this website, which is Google Earth. So you give it a second or two to load. And you guys are going to be getting in your breakout groups. And what you're going to be doing is going through each one of these spots here. All right, you're going to be going through each one of these spots from the headwaters to the delta, and you're going to be making some observations. Things like, what does the landscape around the river look like? What's the apparent size of the river channel? Does it look big and broad and shallow, or does it look wide and deep, or narrow and shallow? What does it look like? What's the slope of the river channel, do you think? Does it look like it's really steep? Does it look like it's fairly flat? What type of rocks or soils do you notice? Is it really rocky? Is it like all granite? Is there loose soils around? What type of vegetation is around there? Big trees, tall trees, small trees, plants, grass. What are you seeing? All right. What do you notice about the color or the clarity of the water? So you don't have to do every single one of these things for each stop. But these are the things I want you to start taking note of, and the things that kind of stand out here. All right. So the things you have about notices and wonders, you can put those in little blue stickies, and the things you have questions you have, I should say notices and observations are blue, but questions you have, so like wonderings about the surroundings, you can put in green. And it's kind of an interesting thing. So there's also a couple of words here where it says laminar or turbulent flow. And check this out. Let me present this so you can see it. There should be a link here where it says laminar or turbulent flow. If you click on that, it shows you kind of an idea of what laminar flow looks like. It's basically smooth flow. So if you're looking at the river and it looks pretty placid, that's what we call laminar. It's moving in kind of a flat sheet. Turbulent flow just basically means there's rapids. It's riffly, right? So you can see like white water and stuff on it. That's what we would call turbulent flow. So that's one thing to think about for that one. And then it talks about the river's competence too. You don't necessarily have to tackle these, but basically the competence is how much stuff a river can move. So if it's flowing fast and high, it's going to move bigger rocks than if it's just kind of flowing low and slow. And that's the idea. So this is kind of the beginning, the head slide. And then you just click like this and you can see we're going to follow the Tuolumne River all the way down its watershed. So the first slide kind of gives you this overview. And if you click on this, you can see the Tuolumne River from where it starts in Yosemite and ends in the San Joaquin River. All right, that's the first part. So now you've seen it, you don't really have to go there. So you can all start at slide number 3 here. And the whole goal, excuse me, the whole goal of this is to just spend 25, 30, 40 seconds, somewhere in that. Just look around at the surroundings. And so when you're flying in here, these are just random. I didn't take these photospheres. These are ones just on Google Earth and Google Maps. But this is literally the headwaters of the Tuolumne River. This is where the Tuolumne River starts, right here at Dana Pass. And when it goes to Modesto, this is what flows through Modesto. This is where it starts after going through the different things. So you're going to see on its journey how this drop of water goes from being right here, becoming, what we depend on for our agriculture, for our cities and things like that. So I'm going to give you guys about a half an hour here to do this. All right. So I want you to spend a lot of good time. I want you to get to know the river here. I want you to answer some of those notices and wonders. You can share the screens. You can kind of do them individually as you go stop to stop. But this is our river. And there are a few places, I think, there might be a few places where if you fly into them, I've embedded a little video clip or something like that. I can't remember exactly which ones. I thought it might be some of these, maybe not. But if they are, you'd see them pop up in the right-hand side here. Otherwise, they're just going to be full screen like this for you to take a look at and see. So this is our river, believe it or not. It's pretty amazing. It's our Central Valley communities rivers, the river of all the indigenous people that live along its banks too. But this is what it looks like these days. So I'm going to put you in breakout rooms, and you guys are going to have about a half hour, like I said, 25 minutes, probably more like it, to try to get through all these different stops and see what you notice, see what you wonder about the rocks, the trees, all those other things. And like I said, you don't have to do each one of those questions for each stop, but it helps. All right. And so do me a favor, please be your best to contribute to the conversation. Don't just, sit in the background, be an active learner, contribute to the conversation, and let's see how many of these different ideas you can get on those Jamboards. Okay. And that's where we're going to go. So perfect 6 groups. And let me put the options for 25 minutes or so. Oops, not 254. That would be a long time. We'll start with 25 minutes and we see how we go from there. All righty. So have fun, enjoy it. This is our river, it's our community. Excuse me, have the hiccups. So when we go into here, what we're taking a look at and what we're seeing here is this is a picture of a cross section. So if we were to hike from here to here across this valley in Yosemite, we'd see this kind of broad, gentle U-shape valley there, right? So interesting. Ooh, there's the river. The river is right out here. There's the river way out there. kind of a nice night, nice way. People are enjoying some camping near the river, backpacking. And I gotta say, that's a pretty easy hike to get out to this spot. It's relatively flat the whole way out there in a pretty cool place. I don't think they're supposed to be camping there. I don't think they were quite far enough back, but it's okay. We'll use their picture anyways. So if we go down just a little bit more, we get into Tuolumne Meadows. And here it is near the spring, kind of near Bankful here. So it's not quite flooding, but it's pretty high. Ooh, but look at this. I noticed some what we call cut banks here, where some of these chunks of grass are eroding in. The river cuts underneath the banks and down it goes. Pretty cool. So that's Tuolumne Meadows. Here's Glen Ullin. And these are the falls I was showing you. So definitely looks like the slope is getting a little steeper. There's more kind of turbulent flow here coming over these little, oh, hey, look, just like we learned about last week, these exfoliated sheets, right? So this granite that's exfoliating and making these different pop marks there, going down the river and carrying some of those granites with it when it goes really super duper fast. Such a cool spot. Then you could see it kind of meander through that valley. And then we get to this amazing thing right here, which is California Falls. And turn around. Look at that. Definitely the slope is increasing here. I mean, it goes down pretty doggone fast and pretty quickly. Not something I necessarily would want to fall down or anything, but look how beautiful that is down there. So those are California Falls. Past LeConte Falls and then Water Wheel Falls are just pretty cool. And they're cool just because look at all the water that just comes smashing off over the cliff, off the face of the granite here, just pounding down. And interesting. I noticed there's like this smooth looking rock face here. Wonder what that is all about. Right, and then here's our Grand Canyon to Tuolumne. So here's another little feeder fall. I don't know why this one's, I guess the person when they took this picture wasn't in focus, but a nice other little, I think it's like maybe Illilouette Creek or something like that. That goes in the Merced. I don't know which river creek that is. I'll have to take a look. But you can see very turbulent flow. We can see all the bubbles and the water in it, and running pretty quickly here. But I also noticed like there's not as many pine trees down here. It's just really rocky and kind of looks like, I don't know, oak tree maybe of some sort, or bay tree. A few pine trees there. So I wonder if it's warmer down in the canyon there. Oh, was that Cathedral Creek? Is that what it said? All righty. So then it flows down into our friend Hetch Hetchy here. And we'll talk about this reservoir as a whole class, but San Francisco built this dam on the Tuolumne River in the national park in the early 1900s as a response to the earthquake in 1906 that really affected their water transportation. So Wapama Falls is right here. These bridges you go across and you can see you can kind of get wet in some of these areas, which is kind of interesting and kind of cool. Just many people have been swept off these bridges before when the water is high. It floods and can knock the bridges out and knock people off. So if there's water going over the top of them, don't be the person to go across them. It'll knock you on your keister and then you'll be smashed down on these rocks and it's not good. But in drier times or when it's not peak runoff, it's a pretty awesome place to go check out. So here's the Hetch Hetchy Dam, older, lower resolution photosphere, but you get the idea. Ooh, look at all the water coming out of the dam. Look at all the water coming out of the spillways here. So here the lake was very, very full. Pretty amazing to see. It's probably not like that right now these days. And then the Tuolumne carries on. So through the Tuolumne River, down into the Pupano Valley, kind of a funny name, but you can see it starts meandering again. And this valley where Hetch Hetchy was too, Hetch Hetchy Valley was very flat. People compared it to a second Yosemite Valley. It was like a little Yosemite Valley, basically. Just an amazing idea of what it looked like. Maybe I can find a historical picture of Hetch Hetchy. Let's try that. Yeah. Oh, historic photos. Let's see here. Yeah, that's before SAS. So you can see what it looked like before everything was dammed, right? There's a nice big valley down in the bottom there. Palma Falls. Yeah, and here's kind of another great picture of what it looked like before the water was there. Maybe I'll copy this image address and put it in the link and tour a little bit later on. But that's why it was nice, kind of flat, and you get this, looks like a flatter river here. I also see some burned trees and things. So just kind of interesting to look at. All right, so now we go from those nice kind of meandering valleys to pretty steep mountains on either side of us still. But this time, if I look over here and I were to draw a profile across the river right there, no longer does it have that nice kind of U shape, but it looks more of a V shape. So we're going to figure out why that is in just a minute with the rest of the class here. Right, look at the bigger boulders here, still all granite for the most part, washed down from the valley and washed down from all the other places before the dam was there. And then, you know, some of it can fall into Pupano Valley below the dam and get washed in big flood years. And then it flows into Dom Pedro. And so this is the upper end of Dom Pedro, but this was the Tuolumne River and still is. If it gets low enough, you can see it, but this is the Tuolumne River arm. And all that water flows in from the Sierras and gets dammed up by Dom Pedro, which you'll see in just a moment here. So here's that Dom Pedro Dam. It's a pretty amazing place. So I don't have any pictures or anything here for that, but you can see that. And there's a hydroelectric power plant down at the bottom. Believe it or not, this dam is over 50 years old now, or right at 50 years old, built in the early 70s. And here's a Dom Pedro spillway. And what's kind of cool about this is here's a little video from 2017. The last time Dom Pedro was completely full to the brink, and there was more water coming in than could be stored, so they had to send water out of the spillway. And when they do that, it goes across the road to Fleming Meadows. And so this is only one or two spill gates open. It wasn't really a huge thing, but you'll see a person standing on the edge here in just a minute. So it gives you an idea of just, there they are. There's like three people there, person there, watching the water go straight down. And as it goes through these different areas, the gates, let me see the downstream, here it is. You can see there's a lot of power there. And eventually it flowed across the river here, across the road, and then goes down and joins the river down here. So by putting the flood over there, it prevents anything from spilling over the big dam. It's kind of like a release valve, and it sends water down and around all the way over to the river down here. But you can see when it does that, there was never like a big river here before, so it eroded and cut down quite a bit to expose some really interesting rocks over there, and leave some pools and deposit some of their sand and gravel. And we'll figure out why that is a little bit later on. And we'll talk about the LaGrange Dam a little bit later on, but this is where this was the first dam on the Tuolumne, built in the late 1800s, and diverted water down these canals to Modesto and to Turlock. So this is where the irrigation water starts. And this was the end of the salmon runs, the big ones, because there was no way around these dams to get into the 50 plus miles of spawning habitat that were blocked when those dams went in. And so here's some more spawning ground information about this. You can see also there's kind of a nice big kind of a terrace is what we would call this. Terrace, terrace. All right. And here's what they're doing about the salmon runs. So if you ever get a chance to float the Tuolumne down by LaGrange, you can totally do that. Tuolumne River Trust has information. I wonder if they're doing any tours here. Yeah, looks like it. But you don't have to pay. If you have a canoe, you can go do that with them as well. Righty. Let's check in and see how everybody's doing here. Awesome. Nice. Really good. And so one of the other things along the Tuolumne River, right, the ancestral Tuolumne River, when it ran higher and was running over here, brought gold down from the foothills and deposited them in places like this. And so in the late 1930s and 40s, they had a big gold rush here, and they had gold mining dredges basically mining up gravels. And that's what you're seeing here, the kind of the tailings of that. Excuse me. Ooh, excuse me. But basically what you're seeing here is this old gold dredge, and it still floats in its pond. And oh, hello, is this Ryan there?
Yeah, sorry about that. Am I interrupting something?
No, nope. I was just kind of narrating some of the folks for the recorded version. Can I help you, or you need to go back, or do you get booted out or something, or?
No, I saw there's only like 3 minutes left, and I had a question
Oh
that
yeah,
kind of
yeah.
seemed dumb that I want to get to in case you had something to talk about after with the time
No,
limit left.
give me a second here. Let me pause the recording, resume recording, and then share my screen again. So I hope you guys, I think all the questions I saw in there were awesome. And I hope, putting the teacher hat on and kind of giving you the teacher trick for those of you that might become teachers. You can't just dive in and talk about rivers if you've never experienced one. And even though we live in the Central Valley and we live so close to these areas here, very few people go out and recreate at our rivers. And the Tuolumne River Trust is trying to, put new trails and things like that in Modesto and build new trails and parks so that we can go enjoy these places. And so by doing this, by at least giving you a little bit of a virtual tour, you have some ideas in the back of your head now as we start talking and going forward. So Ryan has some great questions. Anybody else have any big burning questions that maybe I can help address, or notices or observations that you're like, man, I need to ask about that or something? They were great on the Jamboards, but because I'm here. So nobody asked about the dredge, which I thought was pretty interesting, but right outside of LaGrange, there's a gold mining dredge here. And during the ice ages, when the rivers were flowing much higher and stronger, they were bringing gravels and flowing, across this whole entire floodplain. It wasn't quite in the channel it's in today, but those rivers flowed over here, even during the last 6 to 10 million years or so. The rivers would flow over here, and then their channel would change, but it would deposit gravels up from the Sierras and up from the foothills where there were gold-rich mother lode veins from those metamorphic rocks, and it would deposit it here. And they used gold mining, gold dredging technology, like you see on, I don't know if you ever watched Discovery Channel, the gold dredges that are kind of being resurrected there. But literally these things would dig out their own ponds. The groundwater was so high here that if you dug just a few feet in front, the water table would fill up here. The pond that they dug out would fill up with water, and it would float on its own hole that it dug. So as it dug dirt in front of it, it would wash that dirt and gravel and capture the gold and then spit it out the back of the ship here. And what you ended up making were these amazing, cool tailing piles right here. So literally the ships were floating across land. They dig their hole, make it deep enough so that they could float in it. And as they would move up these stream channels, they would move along forward as they dug the hole deeper, and then they would spit the tailings out in the back here. And if you go over right across from the Grange, what is that dirt biking facility and stuff that's over here, you can go hop the fence. So like a, I don't know, 5-minute walk, and there's the dredge. I don't know if it's public anymore. Sometimes there's a gate there, sometimes there's not, but it's just kind of a cool, interesting piece of gold mining history here. So to go from all the way up into the Sierras, all the way through, the Delta, Turlock Lake actually is formed from the water that comes out of LaGrange Dam here. So this LaGrange Dam, this one was built in the late 1800s, and this is what brought water. This is the main canal for Turlock irrigation. This is the main canal for Modesto irrigation. And if you live in Turlock or you see canal water coming down anywhere in Modesto, this is where it came from. It's literally, I call the canals our piece of the Tuolumne River, right? So it's a pretty cool thing. The bad part with this, basically shut off almost 55 miles of spawning habitat for Chinook salmon. And once the dam started going in, salmon populations started plummeting once water was being diverted away from the stream channels, right? Which has other whole environmental aspects on stuff. So I hope you enjoyed that. You can go out to, there's a whole park near where the Tuolumne River and the San Joaquin come together. There's San Joaquin National Wildlife Refuge. And what used to be farms, now we're working with conservation groups to go out there and replant other habitat. Like trying to resemble and mimic what was on these floodplains before farms came in. So there's some farmers that have basically donated their lands adjacent from the San Joaquin River Wildlife Refuge. And, they're trying to rehabilitate it and make it what it once was a long time ago. So with that being said, let me show you some of the cool things here, and then we'll end for the day and get into the nitty gritty when we come back on, Thursday. All righty. So with those drainage basins then, or with what you just saw, this water coming down, we call these areas that drain the amount of water here, we call them a drainage basin. And so let me go back. I should have put this one first. The Tuolumne River, what you guys just flew down here, this is the Tuolumne River drainage basin. And what that means is any drop of water that falls within these orange lines here, excuse me, are going to fall down a creek that contributes its waters to the Tuolumne River. All right. And you can see that down here in Modesto, it's pretty flat and most things just absorb into the ground and go into the groundwater. But basically anywhere in these yellow lines, that's going to fall in. Excuse me. Sorry, allergies have been bad the last couple of days, ironically, even though the air is super clear. So the water travels down through there. It's a pretty amazing, cool thing to see. So that brings me to what this is called, this watershed, or what we call a drainage basin. In California, the ones that we see most are mostly what we call these dendritic patterns that look like kind of leaf veins. So dendritic means like leaf veins like that. So that's what we see mostly coming out of the mountains. If you go up by like Mount Shasta or Mount Lassen, you see what we call a radial pattern drainage basin or watershed, because it just falls off the volcano, right, and goes in all the different directions. And so this is what it would look like. We don't see many of these patterns. These ones are in the Midwest where there's a lot of limestone. This one is over down in like the desert Southwest, where you get kind of these folded sedimentary rocks that stick up high, and when they erode, some of them leave little spikies that are more resistant to erosion, ridges, I should say, and then the water travels kind of down those and out and around. So what we're going to be taking a look at is mostly these dendritic river patterns, all right, which is pretty cool and pretty amazing. And so what's kind of neat is on either side of the Tuolumne River basin here, we have the Stanislaus River shed, and we also have the Merced River shed, watershed, rivershed, watershed, drainage basin. They all mean the same thing. So if I were standing on this red line here, basically if I was standing on this red line, if I turned north, if I was standing towards Yosemite here, or Yosemite Valley, or well, that's not Hetch Hetchy, I guess, if I was standing towards Hetch Hetchy, and you like spilled your glass of water, it would flow into the Tuolumne. If I was standing in the same spot and I turned around and started facing the Merced River and I spilled my glass of water, that drop would flow into the Merced River. And the same thing with the Stanislaus. And so this red line right here, this red line is what we call a divide. And it literally divides one watershed from the next, and it determines where does the water go, all right, which is a pretty amazing thing. So I do want to share this one website with y'all really fast before we get into talking about the gravity. Let me see here. Oh, I know, I was going to share this with you too. I forgot. The Tuolumne River Trust, which helps out the Tuolumne River and things like that. If you are a person with disposable income, which, you know, I don't know too many college students that have lots of disposable income, but there is a trip. It's a $75 fundraiser, basically, where they take you on November 6th or 7th or the 13th and 14th on a canoe trip down the Tuolumne River to see the salmon run. So you're canoeing down while the salmon are coming up, and they have naturalists and everybody there. It's a pretty amazing, awesome thing. It's kind of steep, but it's a fundraiser that goes to like educational programs in Modesto for all the Modesto City School kids and stuff like that. So you don't need to go with them. They put in at LaGrange and then they float all the way down to, there's a bridge on Highway 132 that goes across. So it's like a 5-mile float or something like that. And they teach you how to canoe, they teach you how to paddle, and it's super fun. But if you have your own canoe or your own good river raft or something like that, you can go and check that out if you want. But I highly recommend. It's pretty amazing that it's there. So this website I'm going to put into your chat. All right. It's called River Runner, and literally you can zoom in and you can zoom out, but basically you have to start with a zoom in. And this one you can try on your own afterwards, but here's what's kind of cool. You can click anywhere here in the United States and it will show you where a drop of water would flow within a watershed or where it comes. So like, for example, if I click right up here by Lassen National Park, kind of in the Feather River Canyon here, give it a second near Quincy, it's given a second to calculate. Oh, hey, look, it finds the river, the water channel here, or the river channel and the watershed. And then it takes you on a 3D animated tour of how that raindrop would flow and where it would end up all the way down at the future. So you can like speed it up and get down to the end, or just make it go faster here. And you can totally see where it ends up, which is pretty cool. And if you ever get a chance, you can do it like in the Midwest as well. And you can see, like, you click out in the middle here. Let's say you're in Nebraska or something, or is Colorado still? So let's just say you click up there. Let's try this. Watch what happens here. Oh, Colorado. All right, so that's still Colorado. Wasn't zoomed out far enough. Oh, this one doesn't go very far. It just kind of gets trapped in an inland stream and doesn't go very far, which is kind of funny. But a lot of them, if you click on it, will go into the Mississippi River and flow all the way out, which is pretty amazing to think about. So the Mississippi River is a huge watershed drainage basin that covers 2/3 of the United States, or drains 2/3 of the United States here. So last thing that we'll talk about here, the last couple of things. Basically, gravity draws water to what we call a base level. So in most instances, it's going to be the ocean, or it's going to be what we call like a desert sink, where it's below sea level, and once it gets there, the water can't go over the mountains, and it just kind of stays there. It stays sunk out in the middle of the desert. And so the headwaters is what we call the start of a river. The mouth of the river is where it ends, and it usually ends in flat, gentle areas towards the end. And we'll talk about what the zone of sediment production and zone of transportation means here a little bit later. And then there's also another word that you need to know for rivers, which is called confluence. And the confluence is where one river or creek joins another. So this would be a confluence between the main river and this small little creek coming out here. Where the Tuolumne River and the San Joaquin Rivers meet, that's their confluence, right? Where the Merced River and the San Joaquin River meets, that's their confluence. And that's kind of what we talk about there. So take a look. We didn't necessarily make a profile, but these profiles, what it is basically shows you how does the elevation or the steepness change over time. So you can see the start of the Tuolumne River up here, is darn near at 9,000 feet above sea level. And in this, about 130 miles or 150 miles or so, it flows from 9,000 feet above sea level down to 17 feet above sea level, where it hits the San Joaquin River. So it loses almost 2 miles of elevation in that short amount of time. To put it into context, the Mississippi River starts in Minnesota, believe it or not, and it's only like 1,400 feet above sea level. So it's kind of amazing to think that the whole entire Mississippi River only drops 1,400 feet. In the Sierras, it does that much dropping in just a few miles, which is kind of interesting to think about. So there's our headwaters. Here's the mouth of the Tuolumne, and that's kind of where we'll pretty much end, I think, for today. after I show you stream gradient. So the stream gradient, like I was saying before, is just the slope of a stream. So the steeper the gradient, the more energy a stream has. Doesn't necessarily mean the water moves faster, but it has a decent amount of energy in some of those areas. And because when it's steeper, because it has more energy, it leads to more erosion and can move bigger sediments. And this is what can downcut and create canyons. So this is something we'll come back around to on Thursday. If it's flowing more gently, like over in LaGrange on this picture, it's generally going to have less energy. It's not going to erode as much, and it's going to move smaller sediments and create some meanders. So steep gradient, just like you guys saw in the virtual tour, waterfalls, water is going to be moving faster, have more energy. And when we have floods like we had the last few days, those are going to be able to move much bigger rocks and boulders and have more erosive ability to cut down. And then when you get into the flatter areas, you're going to get gentle gradients and you're going to get side to side meandering. So no more down cutting, not making canyons, just going to make meanders going side to side. And so here's a gentle gradient. This one's about 50 feet per mile, somewhere in that neighborhood. All right, which is pretty cool. And there's that sheeting from the erosion we talked about last week, right? The exfoliation, the sheeting in the granites here, and makes really beautiful really beautiful little water features on the upper Tuolumne if you ever get a chance. So that's where we're going to end for tonight, for today. We'll come back looking at sediment transport and how river banks, and looking at some of the features, how rivers banks are cut, and looking at cut banks and point bars and all sorts of really interesting things as we come back on Friday. So that's what I got for today. I hope you've enjoyed at least looking and getting to know your river a little bit. You can start heading out to LaGrange and looking for salmon over the bridges in the next, probably this week. You'll probably be able to start seeing some salmon coming up if they're there. Historically, when I was a little kid, there was over 3, 4, 5,000 salmon a year coming up. Now we're lucky if we get about 150 or 200. It's a pretty cool thing to be able to go see them swimming upstream and spawning. So that's what I got for today. I hope you have a great afternoon, and I'll see you on Thursday, and we'll leave it at that. All right. See you later.